All right, guys, this is a continuance of 7.1 talking about interior and exterior angles of polygons, and you should have just finished or have already finished the interior and exterior angle foldables, the sum and the individual ones, and then remember you should have also written the definition of a regular polygon in your interactive student notebook. All right, so we're going to follow up with just some examples. So the next 2 pages are 5 examples. And some of these you will see the same type on your test. So please make sure you pay attention, you understand them, and then you ask questions if you don't. All right, so example 1 shows that the coin shown is in the shape of a regular 11-agon. Okay, so let's stop there. Okay, so this word, the regular, tells us that all sides are equal or congruent and all angles are congruent. Okay, and then 11-agon tells me that my n is equal to 11. It's 11-sided. Okay, so part A says find the sum of the measures of the interior angles. Okay, find the sum of the interior angles. So if you go back to your foldable, you should be able to find that the sum is just n minus 2 times 180. That's the formula we're going to use for all of them. Okay? And of course, my n in this case is 11, so it'd be 11 minus 2 times 180. Well, 11 minus 2, guys, is just 9 times 180. And 9 times 180 is 1,620 degrees. All right, so part B says find the measures of an interior angle. So we want the measure of one interior angle. Okay, so we know that all of the interior angles are congruent. And we know they sum to 1620. So we want to say how many, if we divide 11 angles equally among 1620 degrees, what is the measure of one angle? So all we're going to do here is the sum of all interior angles, which is 1620, we just found it, divided by the number of angles, which is 11. Okay? And you should have gotten that each angle is roughly 147.3 degrees. That's okay if you get a decimal. All right, part C. It says find the sum of the measures of the exterior angles. Guys, this should be easy. So go look at your foldable and how many degrees is in every polygon's exterior. What's the sum of every exterior angle's polygons? The sum of every exterior angle is just 360 degrees. Okay? So then part D tells us find the measure of an exterior angle. So 1. So once again, we're dividing 360 equally among 11 angles. So 360 divided by 11. 360 divided by 11 is 32.7 degrees, and I'm going to change that from equals to approximately. All right, let's look at example 2 now. It says the sum, I'm going to highlight sum, of the measures of the interior angles of a convex polygon is 1440. Classify the polygon by its number of sides. All right, so this is different than what we've done so far. Okay, we know what we've learned is the sum of the interior angles equals n minus 2 times 180. Okay, that doesn't change, and we're going to use this to find it. Okay, the difference is before we had the n and we didn't know this, but now we know the sum and we don't have the n, but we're going to treat it the same way. Okay, so we're going to substitute. Well, we know that the sum is 1440, so I'm going to substitute 1440 for the sum of the interior angles. So 1440 equals, I don't know my n still, n minus 2 times 180. Okay, well, notice I only have one variable, so I can solve it. All right, now some of you looking at this, you want to start distributing, which is fine. You're just making more work for yourself, okay? So rather than start distributing, let's just divide both sides by 180. Okay, and if we just divide both sides by 180, those go away. 1440 divided by 180 gives me 8, so 8 equals n minus 2. Well, plus 2, my 10 equals n. So remember what n represents. N represents the number of sides. So we have a 10-sided polygon, which is a decagon. All right, now I want you to try to go through and do example 3 on your own. Ask yourself, what kind of polygon is this? What is the sum of all the interior angles? And then solve for x. So try this one on your own, and then we'll go over it together. All right, so hopefully you've gone through and at least attempted this on your own. But I'm going to walk you through my thought process and how I got to the final answer. All right, so I look at this figure, and I know this has 1, 2, 3, 4 sides, so it's a quadrilateral. Has 4 sides, so I know my n is 4. Okay, and then I know that the sum of all interior angles is n minus 2 times 180. But remember, my n is 4, so I'm going to replace or substitute 4 in for n. And when I do that, and I do a little bit of math and plug some things into my calculator, I get that the sum of all interior angles of a quadrilateral is 360. Okay, so in other words, if I add this angle plus this angle plus this angle plus this angle, they would all add to 360 degrees. Okay, so I set up an algebraic equation showing that right here. And then I did a little bit of algebra, and I got x equals 72. So this angle over here is 72 degrees. All right, let's look at example 4 now. It says a home plate for a baseball field is shown. So this pentagon looking thing is what a home plate looks like. So question A says, is this polygon regular? Explain your reasoning. Okay, well, you can't answer this question if you don't know what a regular polygon is. Remember, you should have written this down in your interactive student notebook. If you didn't, please go back and do that somewhere. Okay, so a regular polygon has all sides that are congruent and all angles are congruent. So if we look up here, we know angle A, angle B, and angle D are all right angles. Okay, and then we know that angle E and angle C are congruent, but guys, these are clearly obtuse. They are not right angles. So right there, we can say, no, it's not regular. I can say angle A, angle B, and angle D are right angles, but angle E and angle C are obtuse. So I'm going to put also not all angles congruent. Okay, so that is why it can't be a regular polygon. All right, so let's find the measure of angle C. And when I say angle C, I mean this angle right here. Okay, we just said that these two are the same, so I'm going to call this X and X. Okay, now what I need to find out is if I add this angle, and this angle, and this angle, and this angle, and this angle, what would they all add to? So I want to find the sum of the interior angles. Okay, and if we look on our foldable, we can find the sum of the interior angles by n minus 2 times 180. Okay, well, 1, 2, 3, 4, 5. My n here is 5 because I have 5 sides or 5 angles. So I'm going to substitute that 5 in for n. So I'm going to say 5 minus 2 times 180, which is just 3 times 180. Which is 540. Okay, so if I add all these 5 up, they all add to 540 degrees. Okay, now I can go a step further. So now I can say that angle A plus angle B plus angle C plus angle D plus angle E is 540. Angle A is 90. Angle B is 90. Angle C, we called it X. Angle D is 90. Angle E, we called it X, equals 540. Okay, so that's just 90 plus 90 plus 90 is 270, plus X is 2X, equals 540. Minus 270, minus 270, I get 2X equals 270. Divide both sides by 2, I get 135 degrees. So that should be your answer. All right, here is example number 5. And here we're talking about exterior angles. So this is an exterior angle, this is an exterior angle, this is an exterior angle, and this is an exterior angle. So if you remember exterior angles, it doesn't matter how many sides they have, they all add to 360. Doesn't matter if it's a quadrilateral, a pentagon, an octagon, a nonagon, a 58agon, doesn't matter, they all add to 360. So I want to set up an algebraic problem. It says 89 plus 67 plus x plus 2x equals 360. Okay, and then if I add these, that gives me 156 plus x plus 2x is 3x equals 360 minus 156. I get 3x equals 204. Divide by 3. I get x is 68, and that is my final answer.